I really want to thank Dr. Nagler, Dr. Moti, and Thierry Faucon for inviting me. And also great to be in the august company of Ken Anderson and Thanos Dimopoulos. Thanos, you've helped my career from the beginning. I have no conflicts to disclose. Dr. Moti asked me to talk about an era of advances in myeloma, and I was not sure whether he wanted me to go through the last era or talk about the future. So I tried to do a little bit of both. So let's just quickly review what really happened in the last 10 years. Well, a lot has happened in myeloma, and as Thanos said, we have made more progress in myeloma than probably any other cancer in the last 10 years. If you look at diagnosis, we have, because of new laboratory tests, MRI, PET, CT, and the free light chain assay, as well as other biomarkers, we've been able to revise the entire diagnostic criteria for the disease. Because of the work of so many, including Hervé Abet-Lesseau, FISH, gene expression profiling, and molecular methods have helped us greatly accurately estimate the prognosis of myeloma patients, resulting in the new revised international staging system that Antonio Palumbo published. Again, we are able to estimate response very, very accurately. In fact, we are able to detect response so deep that now we have a totally new category of response assessment, minimal residual disease negative state, and that necessitated the revision of the entire response criteria published in the Lancet Oncology last year by my colleague Shaji Kumar. And then finally, a lot of new drugs. There are 6 new drugs approved in the U.S. in the last 5 years. This includes carfilzomib, pomalidomide, panabinostat, ixazomib, elotuzumab, and daratumumab. So we have a huge number of options now for our patients. We've also learned how best to use old drugs. So for example, when I first started using bortezomib, people would say 8 cycles and that's it, and patients will have very severe neuropathy. But that's no longer the case because we've learned to use bortezomib once weekly in sub-Q, so patients can take it. Now I have a patient who's taking it for more than 10 years. We've also learned how to use dexamethasone more effectively, particularly in the context of long-term therapy and in elderly patients. Made big advances in supportive care with the use of bisphosphonates, denosumab, vertebral augmentation. Bone disease is not the same in myeloma anymore. And one of the problems with stem cell mobilization with prolonged therapy, whether it be alkylator exposure or whether it be lenalidomide exposure, has now been overcome by the use of plerixafor. We have a great pipeline, a good bench, a number of new drugs. I have listed 7 drugs here, each of which has single agent activity in multiple myeloma that are yet to come. And then we have a very good understanding of the disease, better than in the prior 10 years. So we've learned lots more about the pathogenesis, what causes MGUS and how MGUS becomes myeloma. The clonal heterogeneity, which is why we are not able to cure the disease. There are just multiple clones. You kill one and then there are still 3 or 4 left behind. We've learned how drugs work. As you heard in the morning, we've finally learned how IMiDs work. And then it seems like it shouldn't work in combination with proteasome inhibitors, but it does even better than that. And so we have to figure that out. But we've learned a lot about the mechanism of action of our drugs. And we've also begun to understand the mechanisms of resistance, which are important if you're going to overcome it. This is similar to what happened with HIV, CML, where once they understood these things, great strides followed. I will just highlight like 4 key studies. I mean, we've heard just about every study that's possible in myeloma precedent since morning already. But just 4 key studies just to see what my take on this is. I think the VRD versus RD SWOG trial is going to be very pivotal because eventually I think VRD will be approved for use all over the world and eventually all patients will have access to this regimen. This shows that even in elderly patients, this study had a median age of probably like 63, 64. 40% of patients were more than 65 years of age, and yet the median survival was 6 years. That actually reflects what was going on in 2007 to 2010 when the study accrued, so that right now the median survival of a newly diagnosed patient is probably much longer. So that's very important to me, and it shows that we can have the IMiD-PI backbone as our standard. This is also eventually going to be an affordable regimen once these two drugs become generic. We've also learned maintenance therapy improves survival, and the meta-analysis that was presented at ASCO in 2016 finally convinced me, I was probably one of the last to be convinced, that maintenance therapy does prolong survival with lenalidomide, and you can see here the meta-analysis showing that len maintenance prolongs survival. This, of course, is important to keep in mind that this improvement in survival you see is only in standard risk myeloma. The high-risk patients had the exact same survival. And for that, we have to go into another study. This was led by Peter Sonneveld, where you can see the red line is patients with high-risk deletion 17p disease doing almost as good as these two standard risk arms with bortezomib maintenance. So that informs us which type of maintenance to use for whom. And then the most recent New England Journal paper of Michel et al. Michel's probably got more single New England Journal papers than anyone in this field here, particularly when it comes to randomized phase 3 trials. When I joined the field, this is the guy I wanted to be like. Michel published the role of transplant in the modern era. And what this study again showed me, beyond all the stuff that we have heard so far, is that right now young people can live 84% probability of living 4 years either with or without a transplant. And that's fantastic. The study also showed, based on the progression-free survival advantage, that transplant still works and has to be included as part. This result is possible only because both arms got a transplant. If you didn't have transplant, then you wouldn't have seen this survival curve. So it's not time to abandon transplant. Transplant's still important. The only thing we can say is that for standard risk patients, the timing of early versus delayed can be adjusted based on what's practical and what the patient's preference is. So based on these 4 studies, the algorithm for newly diagnosed patients has become a little bit more clear now than it was in years past. For patients who are not transplant candidates, VRD based on the SWOG trial, if available, and then Lendex for the truly frail patients. And for transplant candidates, VRD induction, followed by early or delayed transplant, and maintenance therapy, lenalidomide for standard risk and bortez for high risk. This is the past. The question is, what's the future looking like? What do we do for the next 10 years? Or what do we need to do for the next 10 years? And I gave this portion of the talk in New Delhi, and Dr. Modi said that this is something that I should highlight again today. There are a number of advances that we have made, but more needs to be done. The first big question that we need to address in the next 10 years is how do we address the genetic heterogeneity of this disease? This is not one disease. It's like simply saying lymphoma. That's not one disease. Multiple myeloma is not one disease. It is, you can, just as you divide mantle cell lymphoma and CLL as 2 separate diseases based on the 11-14 translocation. Similarly, myeloma is also multiple diseases. At least 6 different subtypes can account for more than 90% of myelomas. Those include the 5 recurrent translocations and then the trisomic. Trisomies are about 40-45% of myelomas. 40-45% have one of these 5 translocations. Now, each one is really molecularly a distinct disease. And by collectively combining them and pooling them together, we may not be able to really cure this disease because we are trying to merge multiple heterogeneous conditions together so that the result will be very erroneous, and not only that, it will be hard to dissect. What we have learned so far are all incidental. We didn't plan it, but we've learned it along the way. That is, early transplant and bortezomib are critical for 414 and del17p patients because the only studies in which these 2 group of patients have done well are studies in which they had early bortezomib, they had transplant early, and they had bortezomib-based maintenance. The second thing we've learned probably is transplant done back-to-back may overcome the deletion 17p effect. Now, whether this is true in the VRD era, I don't know, but I'll be waiting for this kind of analysis from Stamina. Lenalidomide works particularly well, exquisitely well in trisomic patients who have any of the odd-numbered chromosomes, an extra copy. And then finally, venetoclax works particularly well in the 11-14 group. These are all incidental lessons learned. What we need to do is to really do randomized trials in specific subtypes of multiple myeloma. Now, myeloma is not a common disease, unlike, it's probably 1/3 as much frequent as lymphomas. So it's really difficult to do randomized trials in just 4-14 myeloma or just 11-14 myeloma. But we could possibly do comparative effectiveness studies. A while back, the Institutes of Medicine under the National Academy of Sciences in the U.S. said that there are 100 big questions that you can answer in the field of medicine, but we have money to answer probably just 1 or 2. So it's very, very difficult to do randomized trials to answer all of these, but it's very easy to do comparative effectiveness research where we can pool our data together. The IMWG can help with this, but pool data from the Greek group, the HOVON, the EMN, IFM, and the US cooperative groups to try and address these questions. Already trials are going on for some high-risk subsets. So, for example, the SWOG trial is only for high-risk myeloma, DEL 17, 414. And you can see here RVD versus RVD ELO. This completed successfully, and the next trial is about to open of KRD versus KRD DARA. So it is possible to do trials, but it's probably more reasonable to do comparative effectiveness studies. The second question to address is, can we cure myeloma? I was listening to some of the talks here, and even my friend Dr. Nikhil Munshi's slide of MRD negative patients, there was really no plateau. Patients continue to relapse. It's really not a surrogate for cure as far as we can see it right now. If you look at progression-free survival, it continues to go down with time. If you look at acute lymphoblastic leukemia in children, it was always curable. You look at this, 1966, there is a plateau in the survival curve. If you didn't think this is a plateau, then 67 to 79, there's definitely a plateau. That means patients stop dying once you cure the disease, even if you stop the treatment. And they were always able to improve on that plateau so that now they are at the 100% level. Well, ALL is a disease of kids, and so kids, if they are cured, they won't die. On the other hand, myeloma is a disease of elderly, so if you cure them, they'll still continue to die of other reasons, could be an argument. Well, that's not true with acute promyelocytic leukemia. This is older patients, 35 to 54, more than 54, and you can see a curable disease, this is how it looks. You have a sharp drop-off of the people who die because of the disease, and then if they are truly cured after you stop the treatment, they will have a plateau in the survival curve. Myeloma, unfortunately, looks like this. Look at any update, it's just relentless progression. As long as you follow them for long enough, it keeps going down. Now, if you take a patient who is 75, and if we can make them live till 85, you won't see the myeloma come back. But that doesn't mean cure. Cure to me is if one of you gets myeloma, and I look into your eye and say, hey, I can give you treatment for a year, and after that, you probably will be fine for the rest of your life. I cannot tell that. I can tell that for large cell lymphoma. If one of you got a large cell lymphoma, I'll say there's a 60% chance after 6 months of treatment, you'll be fine. For life. Same thing with Hodgkin's disease. But we cannot do it for myeloma, and so we shouldn't fool ourselves that we have to get there. That's where we need to go. We cannot widen the goalpost and say we are curing, but we really need to go there. I did an experiment, and this is at Mayo. I looked at all people less than 50 years of age with 4 different diseases. Guess which one's multiple myeloma? This blue line. This is less than 50. And this is the progression-free survival. That means they eventually keep progressing. If you give 10 years, patients, even young patients, will progress. If you take very old patients, some of them would have died, and you'll miss this phenomenon. But if you take very young patients, this is what happens. The top line, of course, is Hodgkin's disease. The second one is diffuse large B-cell lymphoma, 200 patients each in this curve. And then the third one is follicular lymphoma. So follicular lymphoma is not made more progress than us in 10 years, but they certainly do seem to live longer. So we have some work to do, and what I think we need to do is we need to really reassess where we are. We know for sure that continuous therapy, maintenance therapy works. But if we keep doing that, we will never ever find out if we are actually curing the disease, because if you keep treating the patient, you won't know whether you've got cure. In the book War on Cancer, Vince DeVita said when he was deciding that he needs to go after the Hodgkin's disease patients, he did two things. He said, I need 4 drugs which are non-cross resistant, and I'm going to treat patients with metastatic Hodgkin's disease, like stage 3-4 disease. And then I am going to wait 5 years. Second, I will stop the treatment. I'm not going to continue the treatment forever. I will stop after 6 months. And then I'm going to wait 5 years before I report whether I'm curing or not. Now, if we need to really find out whether myeloma is curable, we don't need to do it in practice. Practice, we have an algorithm. But in clinical trials, we need to start designing clinical trials that will say 6 months, 1 year of therapy, and then we stop, and let's see how many people are we curing. And those trials need to be designed, those trials need to be done. I'm happy that in the ASCENT trial and the CAESAR trial, 2 trials in smoldering myeloma, that strategy is going to be implemented. 1 or 2 years of therapy, stop, and let's see how many patients are really cured. We need to do more of these time-limited trials. I would say the challenge to the myeloma field is to see if we can get to large cell lymphoma. 6 months and stop should be the holy grail. That's what we should achieve, or at least 6 to 12 months and stop. And let's see if we can get there. Thirdly, what endpoints should be used for existing trials? Now, for existing trials, it has become very difficult to use overall survival. That is what's demanded by European authorities. Even progression-free survival in the newly diagnosed setting is now 4 years for the first progression to occur. So it's going to be very, very long. We cannot make progress if all our trials read out 10 years from the time we start them. So as many speakers already said, we really need to move on minimal residual disease. Minimal residual disease, we know we can detect it. We know it is an excellent prognostic factor. Again, you've seen the slide. Patients who are negative do well. Patients who are positive don't do that well. This is from our Hervé's study. Now, the problem is the negative patients don't relapse that frequently, so it's hard to do these studies. The second problem is this is a prognostic thing. We have not shown by going after these positive people we are going to make them into this curve. We don't know. We may actually make them worse because they could die of toxicity. You know, it really, like they say in Harvard Medical School, we cured the patient, but he died. You know, he died in CR. That doesn't help anyone. What we need is to see not just whether it's a prognostic factor, but whether attempting to take these patients into this could do more harm than good. We really don't know that. And I'm glad that so many people here today agreed with that sentiment that we really need to do work on that. So what needs to be done is 2 things. One is we need to validate MRD as a surrogate endpoint for overall survival, because that will be a faster regulatory endpoint, and get our new drugs approved faster and our new regimens approved faster. But secondly, we also need to get MRD tested as an integral biomarker so we can use the MRD result to decide what treatment to do. Both those things need to be done, and those studies are ongoing. Here is a study that's planned in ECOG. Patients after finishing 1 year of therapy, transplant maintenance, 1 year of maintenance, would be classified into those who are MRD positive and MRD negative. MRD positive patients, the hypothesis would be they are not MRD negative with LEN, so whether adding ixazomib is going to help. And the MRD negative patients continue LEN for 1 more year. But these are the types of trials that need to be done, and I'm happy, again, this is just one example, but many other, at least 1 or 2 other trials are already planned. We come next to what can we do about access and cost. This is very critical. Obviously, it pains me that the most populated country in the world, China, I went there last year, and they're still using melphalan-prednisone or melphalan-prednisone thalidomide. VRD is a pipe dream, and it's really not acceptable. If you have pancreatic cancer and the new treatment prolongs survival by 2 weeks, well, if the whole of China doesn't have access to that new drug, it's not okay, but it's okay. But if the treatments that we have double the survival by 3 years, and that's not available across the world, that's really not acceptable. The problem with access is twofold. I mean, so these are just not possible. The problem with access is just not one problem. There are two problems. They're interlinked, but there are two separate ones. One is regulatory approval, how to get regulators to agree to approve drugs fast. The FDA is quite fast. Other agencies are somewhat slower. And then the second problem, even if you overcome the regulatory hurdle, is the cost. Can people really afford these things if they're priced so high? In Medscape, there was an article early in January, drug costs are the #1 challenge in cancer care. And these are I'm not talking just about the new daratumumab, elotuzumab problems. We're talking about melphalan, cyclophosphamide, daraprim. Dr. Modi pointed out about my Twitter activity. I just posted a tweet like a few days ago. Daraprim is pyrimethamine. Pyrimethamine was first sold in 1950-something, 53-something. This is an old drug used to treat toxoplasmosis. That drug costs probably $4 in India. It's $45,000 for a 1-month supply or 2-month supply in the United States. Now, this is really not going out of control in terms of outrageous price hikes for generic drugs, and so we need to really do something about it. So what needs to be done? I think the challenge here is for pharma to be convinced that something has to change, because eventually this will become a problem that governments will then decide to solve, and they may put draconian rules that pharma will not like. Secondly, and more importantly, we as leaders in the field, we really need to use our influence. And so this is why it's so important that what Philippe Moreau is planning on doing right now, which is really to set the stage for strict evidence-based practice guidelines so that we can tell the world exactly how we think the best cost-effective way of treating myeloma is, and use clever sequencing. So for example, if you use bortezomib first, and use it to its full potential, and only then use carfilzomib, the cost will be probably half or a third of what it would be if you use carfilzomib first and then try to use bortezomib. So these are the types of guidelines that we can generate and influence pharma, because once your guidelines are followed, then pharma will adjust its pricing. Finally, how do we move from tactics to strategy? By this I mean that we've done a number of trials, and you've seen about 5 or 6 published in the New England Journal, of 2 drugs versus 3, all of which we needed to do. We needed to do those trials because without those trials, these drugs will not be approved, at least in the time frame in which they got approved. Try doing, say, VRD versus KRD. Carfilzomib will be approved 2 years from now, or 3 years from now, because it will be a much harder bar to cross. In order to have access to carfilzomib early, we have all agreed to do the 2 versus 3 drugs. Eventually, it will be 3 versus 4, 4 versus 5, and there is no end to these tactical trials. There will be winners. They will get our drugs approved. We need them because all these drugs will be approved in the future with these kind of designs. But we need to do strategic trials. Strategic trials ask big questions. Do we really need to cure myeloma, or is it controlling is enough? For example, I have a patient, she's elderly, she's 65, 70 years old, and even the slightest extra dose of chemotherapy makes them feel quite bad, and the quality of life goes down. Started with a monoclonal protein of 3 or 4. 6 months have gone by, monoclonal protein is 0.8. Do I really need to get it to 0? I can get it to 0 by adding a couple more drugs. But will that really make her better? Is that really going to cure her? Is that really going to improve her lifespan? Or is it really going to improve her quality of life? We don't know, and we are not asking questions in those kind of trials. Can we prevent the progression of MGUS and smoldering myeloma? Should we intervene when we see the first paraprotein relapse, or should we intervene only at the time of symptomatic disease? Should we change our therapy based on how good the response is? These are strategic questions, and these are the types of trials that are very hard to do because, of course, it's very difficult to convince pharma to take on these trials. Cooperative groups don't have the type of funding you need to do these trials, so probably we need philanthropic foundations to help. I think, judging from responses from many people, this is the way of the future, that we are going to have to work together. The MMRF has done this very successfully, bring donors and use donors' funding to do these kind of big trials. I will close with a few more slides, but before I do, I just want to put one thing up. I'm a very big fan of the IFM. I've always said that they've done the hard trials. Should I do a transplant? Yes, no, done. Check IFM. Should we do one or two? Check. Should we do melphalan 200 or melphalan 200 plus radiation? Done. Should we do thalidomide plus melphalan? Is that going to improve survival or not? Done. And the list goes on and on and on until Michel et al.'s 2017 paper. I did a PubMed search really quickly. I cannot count because it's very difficult to make a correct estimate, but there have been at least 60 to 70 studies done by the IFM on clinical trials in the last 15 years or so, of which about 40 or so are clinical trials. And so this is a very huge group, and I put this slide up only because I think some of these questions that I raise, only you guys can answer. And I would challenge you to go for it, because it's very, very hard to do clinical trials in the U.S. I wish I could move here and then, be part of this exciting journey. It's not just unique to the IFM. I should say the PETEMA group, Hovan, EMN, Antonio Palumbo, and others also have done outstanding work. I will close by highlighting just 5 of my contributions to the medical field, just as an example. It's not possible to do all of this without a huge group at Mayo, and here is a huge army of people, starting with Bob, Kyle, Phil Greit, Maury Gertz, and so on, who have helped me get to this point. One of the papers I'm very proud of is this paper where we looked at the role of the serum free light chain assay in risk stratification of MGUS. Every one of these papers, there's some other person who has helped me, otherwise this wouldn't have been done. This one is Jerry Katzman. Only Jerry would not blink an eye when I go to him and say, I would like to run free light chain assay on like 1,000 samples within the next month. Can you do this? And he did it. And we published this paper. This is important because what this risk stratification paper says is that 40% of MGUS is very common, 3% of the population. But 40% of that is low risk. They hardly ever progress to myeloma-related disorder. In this group, our data and the Italian data together suggest that you don't need to do a bone marrow at baseline. You don't need to do X-rays or imaging at baseline. You can just diagnose them based on your clinical gut feeling. And the low-risk MGUS, that is less than 1.5 IgG normal light chain ratio, only 2% lifetime chance of ever getting myeloma-related disorder. So that's a lot of cost savings and value that you can add to care. The other study that I'm proud of is the thalidomide study. Bart Barlogie has told me that I milk the thalidomide cow better than most people. I did do a lot of thalidomide trials, but this one was the first trial to lead to the approval of thalidomide in the United States. This was done in as part of the ECOG group. Again, the person who helped me do this was Phil Greit. Phil Greit, I just finished fellowship, and he made me PI of a randomized controlled trial in the U.S., which is why I was able to make a rapid impact on the field. So I really thank Phil for that. The E4A03 trial has been mentioned before. Dr. Moti pointed out the low-dose dexamethasone saves lives and improves quality of life. I do want to thank Michael Katz. Michael Katz was a patient with multiple myeloma who was part of the ECOG group, and while we were planning like very high novel types of designs. He told us, listen, patients are suffering with high-dose dexamethasone. Why don't you please first try and see if this much dexamethasone is needed when you have lenalidomide and thalidomide and bortezomib. And so please do this trial. So this very unsexy trial was approved by the NCI for us to do, and it of course showed that we can save lives by using low-dose dex, and then the RDS regimen has now become the backbone of most of the myeloma treatments we use today. Again, thanks to Thierry, who then took it on to a phase 3 trial, the first trial, and proved its usefulness. The clinical course and prognosis of smoldering myeloma was one of many New England Journal papers that I got just because I'm associated with Bob Kyle. Bob Kyle just virtually adopted me when I joined at Mayo and helped my career immensely. This is a paper that's very important because I really became fascinated with this entity of smoldering myeloma. It had a very nice, catchy term, and by studying it, we started to realize that this is really what myeloma should be. And if we intervene at this stage is probably when you can really cure the disease. And so the natural history risk stratification of smoldering myeloma in this paper was very huge. Finally, the International Myeloma Working Group updated criteria for myeloma. This, of course, as Elena said, is a paradigm shift. I would want to thank many people here, particularly Thanos Dimopoulos, because we two together did many of the studies. Once we had the idea, we had to actually then do all the original research studies to validate each of the biomarkers. And Thanos and I together, we were able to work on at least 5 studies to validate each of these biomarkers, and then of course the MRI studies that Helen Gass did. This paper is a paradigm shift because it allows us to now treat myeloma before the onset of end organ damage, and moreover use advanced bone imaging to follow these patients. So these are just 5 examples. I will close with this paper that Mohammed Moti mentioned, which is Madras to Minnesota. Well, when I first got the call from the Lancet that they want to write about me, I was not sure whether they're getting the right person, because I thought they only write about dead people. But I don't know for what reason they picked me still, but he interviewed me for a very long time. It showed my interest in Megadeth. But more importantly, the paper, since it was published, many people have written to me because it shows a couple of things that are true of all of us, which is perseverance, because it took me 3 tries to get into medical school. 82 I tried, couldn't get in. 83 I tried, I couldn't get in, and 84 I finally got in. So perseverance definitely pays. And then passion. Passion is important because all of us have passion. That's why we've been able to do so much. You're passionate about something, you can change things, you can make things happen. So I think these are lessons that I've learned that I just want to share with everyone. I want to thank the organizers. This has been great. My family is not here, so maybe I can borrow yours.